Alright, we're going to talk about angles today. First little refresher is the definition for array. Array is an object consisting of one endpoint and continues infinitely in one direction. So you got an endpoint and it goes to one direction infinitely. It goes all the way to infinity. So there's array. Now we're talking about angles today. An angle is an object consisting of two rays. Those rays are called the sides of the angle, with a common endpoint, and that endpoint is called the vertex. So if I have one ray here, another ray that has a common endpoint, so it starts from the same endpoint, those two rays together create an angle. And remember, the rays are the sides, so this is a side and this is a side, and then that common endpoint is called the vertex. Okay, so let's name each of the following on this first example. We got this angle here. We want to name the sides. Remember that the sides are rays. So if we're asked to name the sides, we're giving the names of rays. So I have this side is ray BA, and this side over here is ray BC. Remember, when you write the name for a ray, the order of the letters is very important. Because if I say ray AB, it starts at A and goes this way through B to infinity, which is not the same ray. So ray BA, ray BC. The vertex of the angle should always be the first letter whenever you're writing the name of those rays. The vertex is point B. And naming the angles. Most of the time we'll name an angle with three letters using 3 points. And they have to go in an order where if I started with the first point and went to the second and then to the third, that it would draw the angle. So one thing I could call this is angle ABC. You see, if I go in that order, ABC, it would draw the angle. So that's one possible name for this angle. Now I could flip that around and go the other direction, and I could call it angle CBA. Angle CBA. Now don't think that order doesn't matter. Now as far as these two go, either one is fine. But you should notice something that's consistent. The vertex has to be the middle letter. Anytime you're writing the name of an angle, the vertex has to be the middle letter. Now another thing we could call this angle is angle B. Now we cannot always do this. You can name an angle with just the vertex as long as it's the only angle at that vertex. So right here, I say angle B, you know exactly which angle I'm talking about because it's the only one at that vertex. If I'm looking at this picture, however, and I say angle P, might be a little confusing which angle we're talking about. So we only name it with the vertex by itself if that's the only angle at the vertex. Now those are the only three ways we could name this angle, and understand those are three different names for the same angle, not three different angles. But one other way, sometimes they will put a number in here. So let's just say that we had the number 2 sitting here already. If that was the case, then we could also call this angle 2. Now don't get that confused with the measurement. If it says 2 degrees, then that's the measure of the angle, not a name of the angle. So make sure there's not a degree symbol there on that number before you use it as a name. Alright, example 2, how does the diagram in example 1 differ from the diagram in this example? And all we're really trying to get at is, in this one there's only one angle. Here, while there's still only one vertex, there are 3 angles. We have angle QPR, this angle right here. We have angle RPS, this angle right here. And we have the big angle that contains both of the smaller angles. So we got angle QPS, so the entire angle. So we got 3 angles here. So this diagram has 3 angles. They are angle QPR, and if you wanted to call it RPQ, you could do that. But again, you can't just call it angle P because we got multiple angles at that vertex. This angle, we got angle RPS. And we got the big angle, angle QPS. And something I forgot to stress just a moment ago when we were talking about naming angles, it's very important that you include that angle symbol. If I don't include that angle symbol, remember this is plane ABC. So if we're naming an angle, very important that we put that angle symbol in front. All right, an angle separates a plane into three distinct parts. If I draw an angle here, if there is a point in this area, then that point is on the interior of the angle. If a point falls in this area, might be able to guess it, that is exterior. And then there's one other place. If I'm just randomly putting my pin down, picking a random point, sometimes it's going to be on the interior, sometimes it's going to be on the exterior, and sometimes it's going to fall right on the angle. So you can say this a couple different ways. We're going to say the angle itself, or you could say on the angle. So when you have an angle, there's an interior space, an exterior space, and there's the angle itself. All right, using the picture from example 2, let's name a point in the interior of angle QPS. So angle QPS, that's that entire thing, right? Where's a point that's on the interior of angle QPS? Hopefully you see that point R is on the interior of angle QPS. B says name a point in the exterior of angle QPR. QPR. So I'm shading in the interior space. We're looking for a point that's exterior. Hopefully you see that S is exterior of angle QPR. All right, from that picture we just had, we're going to talk about the angle addition postulate. We just learned about the segment addition postulate recently. Remember, the segment addition postulate is if you take a segment and you split it into two parts, that those two parts have to add up to equal the whole. If I'm going on a long trip and I'm going to break the trip up into two parts, so I drive 100 miles, stop, spend the night, drive another 70 miles, I can add those two parts together to get the length of the entire trip. 100 plus 70, I know my trip was 170 miles. The two parts add up to equal the whole. This is the same concept, just with angles. Okay, we have a big angle here, angle QPS, and this ray right here is splitting that large angle into two smaller angles. We now have angle QPR and angle RPS. But if I take the number of degrees here and the number of degrees here and I add those together, then I get the measure of the larger angle QPS. So the two parts add up to equal the whole. And that's all this is really saying. If I'm reading through the formal definition, it says if R is in the interior of angle QPS, so we got angle QPS, you can see R is on the interior, then the measure of angle QPR, this angle, plus the measure of angle RPS, this angle, equals the measure of angle QPS, the whole thing. These two parts add up to equal the whole. And then the converse is also true. If I know the two parts add up to equal the whole, then R must be on the interior of angle QPS. All right, let's try to take this concept and use it on example 4. It says if the measure of angle PQS, the whole thing, the big one, is 77 degrees, and the measure of angle PQR is 32 degrees, then find the measure of angle RQS. We want to know what is that angle right there. Now remember, we just learned the two parts add up to equal the whole. So that means the angle PQR and angle RQS, those two measurements should add up to equal the big angle, the 77 degrees. So X plus 32, if I add the two parts together, it should equal the whole. So there's our equation, and if you want to solve for X, you just subtract 32 to get X by itself, and you should get 45. So I know this angle is 45 degrees. Now some of you would have solved this without even setting up the equation, and that's perfectly fine. You just recognize, okay, these got to add up to 77, so subtract the 32 from 77 and get 45. And that's perfectly fine. We learned that this angle is 45 degrees. But I wanted to show you how the equation sets up, because when we add variables to the mix, which is what we're going to do on the next example, it's important to understand how to set up this equation every time. Add the two parts together, set it equal to the whole. So it says if the measure of angle AOC is 70 degrees, the big angle is 70 degrees. Sorry about that. The measure of angle AOB is x plus 10, and the measure of angle BOC is x. We want to find x and the measure of these two angles. Before we can find the measure of these angles, you've got to find x first. Anytime you want to solve for x, you got to have an equation. Now remember, angle addition postulate, these two parts are going to add up to equal that whole thing. So I'm just going to add those parts together. X plus x plus 10 equals 70 degrees. So there's the equation. So combine like terms, you got two x's. Subtract the 10. Divide off the 2. Alright, so we find out x is 30. Now we want to know what the measure of angle BOC is. Angle BOC is just x. So whatever x is, that's what that angle is. We just learned x was 30, so that angle must be 30 degrees. We're just substituting 30 in place of x. We know that angle is 30 degrees. Angle AOB is x plus 10. If I substitute 30 in here, we got 30 plus 10. And 30 plus 10 is 40. So the measure of angle AOB would be 40 degrees. Alright, this part should be a quick review. We can classify angles based on the number of degrees. So if you are asked to classify an angle, you're supposed to say if it's acute or right, obtuse, or straight. That's what we're looking for when we ask you to classify the angle. Alright, if an angle has a degree measure less than 90 degrees, it is classified as an acute angle. So an acute angle might look something like this. This would be an example of an acute angle. Hopefully most of you already know the classifications by now. You got them memorized. But if you don't, sometimes the stupider something is, the easier it is to memorize. So I just think these are the small angles. These are the smallest ones out of the ones we're about to talk about. Less than 90 degrees. Small things quite often are cute. Babies, puppies. If it's small, a lot of times it's cute. So just like little angle. Oh, it's such a cute angle. So that's my goofy little way to remember that one. That's how I memorized it when I was younger. So hopefully I was stupid enough you can memorize it if you didn't already have it memorized. If an angle has a degree measure equal to 90 degrees, it is classified as a right angle. So a right angle would look something like this. And with a right angle, we usually put this symbol on it. Kind of makes it look like you got a little square going on here. That's a right angle. Now it has to equal 90 degrees. It's got to be exactly 90 degrees. If it's 89.99999 degrees, still not a right angle. That's an acute angle. It's got to be exactly 90 degrees for it to be a right angle. If an angle has a degree measure greater than 90 degrees, it is classified as an obtuse angle. So there's a possible example of an obtuse angle. So you see how the rotation of degrees is happening. It's getting bigger and bigger. It's opening wider and wider as we go to larger numbers. And then if an angle has a degree measure equal to 180 degrees, it is classified as a straight angle. So if you got one side of your angle going this way, one ray going that way, think about how far does the other one have to rotate around to get to 180. If you think about yourself doing a 180, it means you turn around and you go the exact opposite direction. So from this ray going this direction, the other side of that angle would go the exact opposite direction. And so when you have a straight angle, you basically have a straight line. If you think back, these would be opposite rays. The sides of that angle are opposite rays. They're going in opposite directions from the same endpoint. Alright, so down here, for each of these angles, we're going to name it, and we're actually going to give all three possible names for it. We are going to tell whether its measure is less than 90, greater than 90, equal to 90, or equal to 180. and we're going to classify it. So right here, this angle could be just named angle F. You can just name it with its vertex. If we're naming it with 3 letters, make sure the vertex is the middle letter. So we can call this angle YFI. Make sure you're including that angle symbol. And you can go the other direction and call it angle IFY. Okay, the measure of the angle is 35 degrees, which makes it less than 90 degrees. And if it's less than 90, that makes it an acute angle. What acute angle? All right, next one right here. We can name it just with the vertex. We can call it angle T. We can call it angle LTC, making sure that T is the middle letter, and angle CTL. It's 125 degrees, which means it's greater than 90, and that makes it an obtuse angle. Okay, angle down here, we can call it based on its vertex again, angle T. And then when we use 3 letters, we'll make sure that vertex is the middle letter, angle RTS, and angle STR. Okay, the measure, they didn't give us a number, but they gave us this symbol right here. Remember, that means it's a right angle. It means it's 90 degrees. It's equal to 90 degrees. It's a right angle. Okay, naming the last one here. We can call it angle X. That's the vertex. We can call it angle NXS. And we can call it angle SXN. And this angle, you'll notice, is creating a straight line. This is 180 degrees. You got those rays going in opposite directions, and that makes this a straight angle. All right, guys, last page. All right, when angles have the same measure, they are said to be congruent. Remember when we talked about line segments, they were congruent if they had the same length, because when we measure segments, we measure them on length. So 5 inches and 5 inches, or 7 centimeters and 7 centimeters, those are congruent segments. Angles aren't measured with a length. Angles are measured with degrees, or at least that's the units we're using. And so if we say 2 angles are congruent, it means they have the same measure. They have the same number of degrees. So a 23-degree angle and a 23-degree angle would be congruent. All right, an angle bisector is a line, ray, or segment that divides an angle into 2 congruent angles. Okay, so if you have an angle, the angle bisector is what I'm going to draw in red. This would be an angle bisector if it makes these 2 angles congruent to each other. An angle bisector goes right through the middle of an angle and splits it into 2 congruent halves. This angle is half of the original angle, and this angle is half of the original angle. And therefore they're congruent. Alright, so let's look at example 7. It says if ray XZ is an angle bisector of angle WXY. Before I read any further, I know that this is bisecting this angle. I immediately mark these 2 angles congruent in the picture so I don't forget that information. Name the 2 congruent angles that it forms. Okay, well, I just marked them. Angle WXZ is this angle. And then this angle over here is angle ZXY. And I'm going to put the congruent symbol in between to show that these 2 angles are congruent. The congruent symbol looks like an equal sign with the little squiggly thing over the top. Actually called a tilde. But it looks a little bit like an equal sign with a little squiggly line over the top. That symbol right there means congruent. So angle WXZ is congruent to angle ZXY. Now if the measure of angle WXY is 60 degrees, if this entire angle is 60 degrees, and we bisect it, we split it into 2 congruent halves, then what are the measure of angles ZXY and WXZ? Well, each of them are half of the original angle, right? So half of 60 is 30. So that's 30 degrees, and that's 30 degrees. All right, one more time, guys. We got two examples we're going to use off of this picture. It tells us ray FG bisects angle EFH. It's taking this angle and splitting it right down the middle into two congruent halves. Now I'm using the same picture for two different problems, so I'm going to make sure I'm using pencil to label the rest of the picture. On example 8, it says the measure of angle EFG is 5x minus 10, and the measure of angle GFH is 3x plus 25. Now we just finished saying that these two angles are congruent to each other, which means they are the same number of degrees. They have equal measures. So while I currently don't know what 5x minus 10 is, or what 3x plus 25 is, what I do know is that whatever they are, they're coming out to be the exact same thing. I know they're equal to each other. So because I know they're congruent, I'm going to set them equal to each other. And we can solve for x now, because that's what we were told to do. Find the value of x. So then we're just solving an equation. So this is just your algebra skills. Remember, if you have a calculator, you can get the calculator to solve the equation for you. If not, we're doing it on paper. I don't want the variable on both sides, so I get rid of it on one side. Once I do that, I want the variable all by itself. So I'll move the constant first. And then I can divide off this 2. X is being multiplied by 2, so we do the opposite operation, and we divide by 2. And there's x for example 8. And I'm just going to erase the stuff that I labeled on this picture for example 8 so that I can do example 9. All right, let's label that picture up for example 9. It says the measure of angle GFH is 3x plus 20. And the measure of angle EFH, that's that larger angle that was bisected. So this larger angle here is 4x plus 80. Okay, hopefully you understand we're not going to do this one the same as the other one. When I look at angle GFH and angle EFH, it's easy for me to see they're not congruent. Now, what relationship do they have to each other? Remember, angle EFH was bisected, split into two congruent halves. That 3x plus 20 is exactly half of angle EFH. It's half of that 4x plus 80. Now, there's a couple different ways you could go about setting up this equation, but I need an equation. I need something equal to something else. They're not equal to each other right now. But if this is exactly half, I can double it, and it would now be equal to the whole. So I'm going to take this angle that's only half as big, that's half the size of the other one, and I'm going to double it. I'm going to multiply it by 2. And once it's been doubled, then it will equal the same thing as the larger angle EFH. So there's the equation I'm setting up. And from here, it's just solving it, just the algebra. So first step, we got to distribute. 2 times 3x is 6x. 2 times 20 is 40. We don't want the variable on both sides. I'm going to get rid of one. I always get rid of the smallest one. So I'm subtracting 4x. That gets rid of it on this side, and all we have on that side now is 80. We want x all by itself. I'm going to get rid of the constant. It was being added, so I'm doing the opposite operation. I'm subtracting. And I want to get rid of the 2. X is being multiplied by 2. I do the opposite, divide by 2. And there's x.